So hello everyone, my name is Shivam and I welcome you again in my channel. If you are new here, I am a PhD scholar at IISc Bangalore and I have given more than 16 interviews at 8 different institutes in India, including physics and other related disciplines. Also, I have made a complete interview series in which I have shared these experiences one by one. So I strongly recommend you to watch those videos before going for the interview. In this video, I will be sharing my interview experience of NISER Bhubaneshwar, IISER Thiruvananthapuram and JNCASR Bangalore. So without wasting any time, let's get started. Okay, so we will start with NISER Bhubaneshwar and I gave this interview in June 2024 and I applied in only physics department under experimental condensed matter area और wherever I gave the interview till now सिर्फ नाइजर भुवनेश्वर में ही रिटन टेस्ट लिया गया था और कहीं पे नहीं डायरेक्ट इंटरव्यू था सारी जगह but only this time there was written test plus interview which was scheduled the same day. So there were approximately 70 to 80 students who applied in physics department and they got the call letter for written test and interview on the same day. So we all gave the written test which was 1.5 hours long and it was totally MCQ based question which was of like easy to moderate level and you can say that jam level questions they gave us. So I cleared the written test, but I don't understand like why did they take the written test? Because out of those 80 candidates, they only eliminated 6 students after the written test and all other students got the chance to give the interview. So they could have taken the interview of all the candidates without taking written test and wasting the time. But okay, it's my personal opinion. Let's forget it. Now, they published the result after the lunch. We gave the written test from 10 to 12 I guess and then we had a lunch. After lunch we got the results that these students are going into the interview round. So my interview was scheduled on the same day in the afternoon session. So after lunch I went there to give the interview. So let's start. As usual, they asked about my background, my introduction, my name and all, from where I have done all my bachelor's and master's. Then they asked me, which subject have you prepared for this interview? So I mentioned them 3 subjects, electromagnetic theory, quantum mechanics and solid state physics. So they started asking me questions from electromagnetic theory. So I was given that there is a conducting sphere and a charge q on it. What will be the electric field? So there is a conducting sphere which is not hollow and we have to find the electric field. So I used Gauss law and I wrote the electric field outside the sphere and inside the sphere. So ये तो आसान था. This was obvious and I wrote the electric fields. Then they told me that there is a cavity inside the sphere. So what will be the new electric field inside the cavity and outside the cavity? So let's say there is a cavity inside this. So what will be the electric field inside this cavity and outside the cavity? Okay. So again I tried to use the Gauss law and find, but I guess they were not satisfied with the answer and my answer was not correct. So they hinted me and asked question on that, how are you using Gauss law and all. So they asked me some questions on Gaussian surface, how do you take the Gaussian surface, can you take any arbitrary surface or there is any fixed rule that how the shape should be. On that they grilled me. So after that they moved to the next subject and they told me which topics in quantum mechanics are you comfortable in. So I thought for 2-3 seconds and I told them that infinite potential well. So they told me to draw an infinite potential well which is symmetric. So I drew this, which is correct. This is a symmetric infinite potential well. So we can say that V of x is 0 between minus ANA and infinity outside minus ANA. Okay. Then they told me to write the eigenstates for this symmetric potential well. These are the eigenstates for this potential. This is an symmetric potential, so there will be 2 eigenstates, cos and sine both. For n equal to odd, there will be cos terms, and for n is equals to even, the wave function have sine function. So this comes from solving the Schrodinger equation with this potential and applying the boundary conditions. Then they told me to draw the states. Let's say the first state or the ground state. Okay, so I drew the graph but was wrong. I drew the psi 1 as this is psi 1 cos x. Okay, let me change the color. So I drew the cos like this. Okay, at the boundary it will be 0, but for psi 2x I drew it like this, which is wrong. It will be like this. it will be like this. Okay, psi2 of x. So finally I arrived at the right graph. They grilled me so much. They grilled me on this graph making, okay, graph plotting. They hinted me also, and I finally arrived at the correct graph. Then they kept asking questions on this graph and wave functions only. So they asked me that will it be 0 at x equal to plus minus a or decaying. So they asked me that at this point or this point, this will be decaying inside the potential or it will be exactly 0 at the boundary. So I told them that it will be 0. So then they asked me that is it continuous at the boundary at x equal to plus minus a. I told them that yes, psi x is always continuous at the boundaries no matter what, and that is a acceptable wave function, and this will be 0 at x equal to plus minus a, and outside a also it is 0, so it is continuous. But I also added one extra point that the derivative of the eigenfunctions will be discontinuous at the boundary in case of infinite potential well. So they asked me that how the derivative is discontinuous, just show us. So then they hinted me and told me to differentiate, let's say psi2 of x, and plot it so that you can show us that it is discontinuous. So somehow I managed to plot. I wrote the wave function again and I differentiated it. Here a is our the normalization constant, and this will be our psi2. I wrote here psi2, and this will be our cos function. Here it is cos psi2 of x. So we can see that this is not 0 at a, and this is not 0 at minus a. Okay, and after a it is 0 because here it is infinite potential. So here the wave function is not there. Here the wave function is 0. Here also the wave function is 0, but at the boundary it is not 0. So the wave function is not continuous at the boundaries. Sorry, not the wave function, but the derivative of the wave function is not continuous at the boundaries. It is discontinuous, and we can see here by plotting it. So how to find this? Like, how did I do this? First, you will find the value at x equal to plus minus a. Sorry, it will be not L, A. We can write anything as a. Okay, it will be A. So first we should find the values of the derivative at x equal to plus minus a and x equal to 0. So we can get the value at 0, a, and minus a. Then we can double differentiate this and get the maxima and minima. Where will be maxima and where will be minima? So these were the hints given by them, and I followed that and I arrived at this graph. So I showed them that derivative of the wave function for the infinite potential well is discontinuous at the boundaries. Next, they asked that the wave function and its derivative should be always continuous. Why it is not the case here? So I told them yes, the wave function and the derivative of the wave function should be continuous, but there is an infinite potential here at the boundaries. So this statement is only true for finite potentials. If we have a finite potential like v of x equal to v naught, then both psi of x and psi prime of x, that is the derivative of psi x, will be continuous always. But in case of infinite potential well, when there is a infinite potential, then the wave function will be continuous, but the derivative won't be continuous. Then they told me to explain why. Tell us the reason why this is so. But I could not answer this question. I didn't know that why the derivative will not be continuous. So then they told me to revise it more, these topics, and the interview ended like this. They told me that you can leave. So this was the physics department interview at NISER Bhubaneshwar, and now we will move to IISER Thiruvananthapuram. I gave the interview at IISER Thiruvananthapuram in December 2024 in the mid-year cycle. So this was completely online and I applied in only physics department. So I got the call letter for the interview. So they started with my introduction and my interest areas. I told them that semiconductors and quantum mechanics. So one other professor asked me that explain the Drude model and show how the expression for resistivity or the conductivity comes. So I explained the origin of resistivity, how the Drude model explains it. I also wrote the formula of resistivity that comes from the motion and scattering of the electrons and lattice vibrations and all. Then they told me to write the Ohm's law in microscopic form. So I wrote it. Then they asked me that can you derive this from V equal to IR? I tried and I did it. Okay, so then they asked me why does the resistivity for metals with temperature increases but not with semiconductors. Then I explained them the concept of electron hole pair generation in case of semiconductors, and as we increase the temperature, the electron hole pairs generation is more and the current is more because the charge carriers has increased. But in case of metals, there are lattice vibration as we increase the temperature, and this lattice vibration causes a scattering of electrons, which in turn increases the resistivity of the metals. So I explained them clearly, the basic idea. So a different professor asked me that, let's say you have a wall clock. Imagine you have a wall clock, and let's say you put a charge Q on every digits of the wall clock, the hour digits, except on 5. Let's say the 5 digit position doesn't have any charge. It is empty. So there is nothing here, okay? At the 5 number position, this is 1, this is 2, this is 3, 5, this is 12, okay? So the question was to find the total force at the center of the clock, okay? So ऐसा question हम पहले solve कर चुके थे, so this was easy for me. I told them that I will consider a positive charge Q on the same place and a negative charge Q on the same place, and effectively there will be no charge at the place. Q minus Q will be 0. So we can assume that there is a positive charge on the 5th place and there is also a negative charge. Now force due to all these positive charges Q on this point P will be cancelling each other. Force due to 1 and force due to 7 will cancel each other. The force due to 7 will be on this side and force due to 1 on this side, they will cancel each other. Similarly, force due to 12 and force due to 6 will cancel each other. So as this is very symmetric, these all forces will cancel each other and the net force on the center will be 0 due to all the positive charges. Only the remaining charge is minus Q, which will generate the force at the center. So I explained them that force at P will be 0 due to all the positive charges due to symmetry, and force will come only due to the negative charge. I have to calculate force at this point due to this negative charge, which is just given by 1 by 4 pi epsilon naught and Q by R. This distance is R, so this will be the force. And also they asked me the direction, so the direction of the force, the net direction of the force will be towards Q, towards minus Q, towards 5. So this is how I answered this question, and the interview got ended with this little amount of questions. And now let's move to the last institute and the last interview. So let's start with JNCASR, which is also in Bangalore. And if someone doesn't know about this, so this is Jawaharlal Nehru Center for Advanced Scientific Research, and it is also a very reputed institute and a very old institute. If you ask me, this is one of the best for material science, condensed matter physics, and chemistry. Biology research is also going on here, and so many interdisciplinary areas. It is a sister institute of IISc, like RRI, Raman Research Institute, and when it was built, when it was founded, it was inside the campus of IISc. Now it has been moved to the new campus, its own campus, which is 12 kilometers from IISc, and it has various departments or units. It is not an academic institute as such, it is a research institute. So this has like CPMUs, chemistry for physics and materials unit, NCU, new chemistry unit, TSU like theoretical sciences unit, NSU, neuroscience unit, MBGU, molecular biology and genetics. All these units are there inside this institute. And as far as the degree is concerned, it gives PhD degrees, integrated PhD degrees in material science and physics and chemistry, master's degree like MS research and MS engineering. These all degrees it provides. So I got the call letter for PhD in 2 departments. One was NCU, new chemistry unit, and the other was ICMS, International Center for Material Science, which is also a part of CPMU. So let's see how it all went. Okay, so we will start with NCU, which was offline. So when I came to give the interview of IISc, the same time I gave the interview at JNCASR, new chemistry unit. So as usual, they started with the introduction and asked me the favorite subjects. Then I told them solid state physics, quantum mechanics and electromagnetic theory. Everywhere I was saying the same topics because this was relevant to them also. So I'm going to give the interview for PhD in the related area. So it was obvious that I should tell these subjects, not other subjects. The first question they asked was the lattice of NaCl. What is the lattice of NaCl? So I told them it is an FCC lattice and 2 FCC penetrating at half distances. So let's say you have a cube. I will draw it and explain. This is an FCC lattice. At the FCC sides there are, let's say, Na atoms, okay, and there will be oxygen atoms at the middle of the edges, here. Then the question was, if you do the XRD of NaCl, X-ray diffraction, how will the spectra look? So I answered like only even and odd planes will be present in this XRD spectra. What I mean by even and odd plane is, if I do the XRD of NaCl, I'll get the peaks from those planes whose HKL values are all odd or all even. So starting from 111, there will be peak of 111, 200 because these all are even, 222, then 333, like that. So they told me to show the peaks how it will look and tell us that which peaks will come first and which peaks will come later. And then I plotted this XRD spectra like this, and I told them that 11 will come first, then 200, then 222, and all. So I explained them this order by using Black's law, which says 2d sine theta equal to n lambda, and this is for n equal to 1. This is DHKL, the distance between the planes. So DHKL will be lambda by 2 sine theta. So DHKL is inversely proportional to the theta or sine theta. And also for cubic system, here in case of NaCl, this is FCC. So the DHKL will be a by under root h square plus k square plus l square. So from these two relations, we can see that theta is directly proportional to under root of h square plus k square plus l square. So smaller the value of these number, smaller will be the value of theta. Okay. So for 111 it is root 3, for 200 it is 2, for 222 it is root 6, and all. So we can arrange this in ascending order. So the first peak will come from 111, then 200, then 222. So this is the increasing order of theta. Then they asked me what is the crystal structure of CSCl. Do you know? Then they asked some questions from quantum mechanics which I really don't remember what they asked. Sorry for that. And then the interview ended. I don't remember the next questions. So it ended like this. They asked 6-7 questions and it was also 20 minutes long. Now let's move to the ICMS interview, International Center for Material Science, and it was online because it was not on the same day. It was a week later. So they started with the introduction and the interest. And also one professor in the panel had also done his MSc Physics from SPPU, Savitribai Phule Pune University, from where I have done. So he told me that he has also done his masters from there. So after the introduction and discussion ended, they asked me that, do you know about spherical coordinate system? So I told yes, and then they told me to write the relation connecting the Cartesian and the spherical system. So I wrote the relations like this, and I also drew the diagram because they told me to explain how this relation is coming. So I drew the Cartesian axis and I explained them how these relations are coming. Then they asked me that if you integrate the elements, the line elements or the volume elements, what limit you choose for r, theta and phi. So I also wrote this. It was easy. R from 0 to infinity, theta from 0 to pi, and pi from 0 to 2 pi. So then again they asked the obvious question that why the theta is going from 0 to pi and phi is going from 0 to 2 pi. So I explained them that how the sphere is forming with this r, theta, phi. Then they asked me to write the Hamiltonian for a 1D harmonic oscillator. So I wrote this. It was simple. 1D harmonic oscillator के लिए, because for harmonic oscillator the potential is half m omega square x square. Okay. I also wrote the energy eigenvalues and n plus half h cut omega, and the wave function I didn't remember the exact formula because they are harmonic polynomials. So it will be proportional to exponential minus alpha x square by 2, and where alpha is this. So then they told me that now let's assume we place a charged particle q on the same system. So how will the Hamiltonian change? Write the Hamiltonian again now. And what will be the change in the wave function? How will the wave function look like now? So I could not answer this properly. Okay. I was not able to figure out what will be the Hamiltonian, correct Hamiltonian and correct wave function. So this interview ended here. It was also about 20 minutes long and online. But at last I got the offer letter from JNCASR from IISER Thiruvananthapuram. The only place I did not got the offer was NISER. Wherever I gave the interview in the normal cycle and August semester cycle and the December semester cycle mid-year, from all of the institute I got the offer letter for PhD. Only NISER Bhubaneshwar is the institute from where I didn't get any offer. Okay, that's it. This was all about my interview experience at NISER Bhubaneshwar, IISER Thiruvananthapuram and JNCASR Bangalore. So if you have any doubt, you can comment down or reach out to me. I will be happy to help. So see you soon in the next videos. तब तक के लिए bye bye.